This example is going to give us a little bit more practice at analyzing op-amp circuits that have the feedback resistors in place, but it's also going to, each one of the results of these three parts are going to be the equation that I told you in the lesson corresponds to that building block circuit. But I don't like for you to have to just take my word for it. So let's derive those three equations, and then you'll be able to see how that result was obtained. The first one is the non-inverting amplifier. And in this case, you can see that we have a couple of things that are going for us. First of all, we know the value of the non-inverting input. We know that that is just simply Vn. And by one of the cardinal rules, we know that means that this voltage right here is also Vn, because the two voltages, the non-inverting and the inverting inputs, must be equal to each other. Now I'm going to go ahead and label a couple of currents here. I'm going to label this as current I1. I'm going to label this as current IF. And then I know that this current right here has to be 0 amps. That's one of the other assumptions that we can make. One of the other cardinal rules is that there is no current flowing into the input terminal. So if I can use Kirchhoff's current law here. Kirchhoff's current law simply says that I know that the sum of the currents entering this node. So I'm going to do Kirchhoff's current law at that node. I can actually sum the currents entering or the currents leaving. I'm going to sum the currents leaving that node for obvious reasons. So I have the I sub 1 plus I sub f plus, I'll go ahead and put 0 amps so that I don't forget it. That's equal to 0. And so you can see that I have one current leaving downward, one current leaving to the right, and one current leaving upward. I've accounted for all three of those currents with this equation. Now I can rewrite the I1, because I know that this terminal right here is Vn, and so I know that this terminal right here is 0 volts. That's the reference node. So I can say that the current I1 is Vn minus 0 divided by the resistance, which is R1. And then I sub f, well, that's the voltage at the origin side, so that'd be Vn minus the voltage at the destination side. Well, that's over here, that's just V out, right? Because that's where the voltage output is taken. So Vn minus V out divided by Rf, and I can omit the 0 amps, this is equal to 0. Well, I'm going to go ahead and multiply both sides through by Rf. So I get Rf divided by R1 times Vn plus Vn minus V out is equal to 0. And then I can move V out over to the other side of the equation. And this ends up, you can see here I have Vn times Rf over R1. This is Vn times nothing, which is just an implied times 1. So this is 1 plus Rf over R1 times Vn. And if you go back and look in the lesson notes, that's the equation that was given for V out versus Vn for the non-inverting amplifier. The second one is a lot easier. The voltage follower, this is also known as a unity gain amplifier. Unity is a word that means one in an engineering world. And so when I say unity gain, that means a one gain. In other words, V out is equal to Vn. There's no gain, there is no attenuation. And so here you can see I know that the voltage here, this is Vn. Therefore, this is Vn. And there's a wire directly connecting, this wire right here is directly connecting to this point, so I know that this is Vn. Well, guess what? V out is equal to Vn. It's as simple as that I can trace by one of the cardinal rules. I know that the two inputs have to be an equal voltage, so therefore I know that this node right here is Vn. There's a wire that connects to this point, so that's Vn, and that's the same node as V out, so therefore V out is equal to Vn. That one's not too hard to derive. This one's a little harder, but still not too bad. In this case, I'm going to go ahead and label a few additional currents. Before I do that, let me just mention, I know that this is 0 volts, and by the cardinal rule, I know that this is 0 volts. So that's very important. I know the voltage at both inputs of the op-amp are 0 volts. I'm going to go ahead and label some currents flowing into the terminal here. So I have I sub f, I have I sub 1, I have I sub 2, and I have I sub 3. And if I do Kirchhoff's current law at the inverting input, then I'm going to have I sub 1 plus I sub 2 plus I sub 3 plus I sub f is equal to 0. Remembering that the current here is 0 amps. So I can now, I can rewrite each of those currents in terms of a voltage difference divided by a resistance. So this is V1 minus 0 divided by R1. Notice it's V1 on the left, and this is 0 volts, so therefore this is 0 volts, so therefore this is 0 volts. Each one of these terminals is also going to be 0 volts. So V1 minus 0 divided by R1 plus V2 minus 0 divided by R2 plus V3 minus 0 divided by R3. And now I need to figure out what is IF. Well, I know the voltage right here is V out. So this is V out minus 0 divided by RF is equal to 0. I'm going to multiply through both sides, the whole equation by RF. So I'm going to end up with RF over R1 times V1 plus RF over R2 times V2 plus RF over R3 times V3, and that's plus V out is equal to 0. And now I'm going to simply move the V out over to the other side, but it's going to introduce a negative sign. Notice that everything here is positive, and so when I move V out over to the other side, I have to say, well, it's equal to negative RF over R1 times V1 plus RF over R2 times V2 plus RF over R3 times V3. And again, that's the equation that is from the notes that describes how this circuit works. Notice that, again, this has been shown with 3 inputs, R1 or V1, V2, V3. It could be done with 10 inputs, or it could be done with 2 inputs. Or if you reduce it down to just 1 input, then notice that what you end up with is V out is equal to minus RF over R1 times V1, and that's exactly the equation of the inverting amplifier. So if you reduce the summing amplifier down to just a single input, it becomes the inverting amplifier. But that's not the answer to this question, so I'm going to go ahead and erase that. But the point is that you can expand or contract the number of inputs as necessary to solve the problem that you're faced with.